Good afternoon, ladies and gentlemen of YouTube. My name is Dan Jones FPV, and today I'm going to show you how to replace an FPV quadcopter motor. Today's motor is this motor right here, the front right, as it is seized up from a crash. This video is geared towards someone who bought a pre-built quadcopter. If you bought a quadcopter pre-built, you may not know how to build, and if that is the case, this video will hopefully help you show you how to replace the motor. If you've built your own quadcopter, well, this may offer some helpful hints upon doing it yourself in the future. Either way, hopefully this helps. The things you'll need is something to cut the tape off if you're, like me and you've taped your motor wires together, or something that's guarding the motor wires. You'll need to remove that, a tool to remove that. A 2.5mm or 2mm hex head, a nut driver sort of dealio. If you look underneath here, you've got, these are 2.5mm, usually no smaller than 2mm, so, and no bigger than 2.5 in most cases. So just get the appropriate tool to remove the screws from the motors. And you'll need your soldering iron. That is up to 400 degrees Celsius, ready to go. And some various tools you'll need to remove the motor and replace it, including your preference of soldering assistance tools. This particular motor is this motor in the box, T-Motor VLOX 2306 2400 kV. If I were to buy, say, a different brand of motor and it was still 2306 2400 kV, I'd be in good shape. It would be fine. More than likely, it would be apples to apples. What you don't want to do is change these numbers drastically, more specifically this one. You can change this one a little bit. You don't want to change the kV. You want all the kVs to match. It doesn't hurt your flying. It just means that one of the motors will be different. If the motor has a higher number, it will be restricted by the 3 other motors. If it has a lower number, the rest of the quadcopter will be restricted by that one. So it is ideal that the kV number match, and as well as what we call the stator size. Beyond that, it doesn't really matter. It can be any brand for the most part. So we got the new motor ready to go. We've got our iron heating up, and while our iron is heating up, we're going to remove the props. Remove the props. Remove the props. Here we go. Now that you have the props removed, we need to cut away anything guarding the wires, whether that be a 3D printed part, some wire mesh cover, anything at all. In this case, electric tape. We want to make sure, though, that we check and see exactly how these wires are attached. Are they attached in order of the wire being from left to right, 1, 2, 3, or are they crisscrossed? If they're crisscrossed, we need to note that and make the adjustment when we attach the new wires. We are now ready to desolder the wires and then remove the motor. So what I recommend you do is make sure that your tip is up to at least 400 degrees Celsius, no hotter. It doesn't need to be any hotter than that. Clamps here we go. 1, 2, 3, lift off. Doesn't take much. If we look here, we'll remove one of them. It looks like they are lined up crisscrossed. You can see wire number 3 is actually crisscrossed over wires number 1 and 2, which means that when we go to attach the new quadcopter motor, we'll want to make sure that they are matching. So we crisscross one of the wires. That ensures that the direction of the motor will likely be correct. We still need to check this, but usually that means it will be done. All right, so doesn't take much heat. You just touch the iron and remove the wire. You don't yank on it, you just touch the wire. And what I'm doing here is I'm cleaning up the pad. Any little gunk that's left over, we want to get rid of. So we are going to now remove the physical motor off the arm. So all we're going to do here is just unscrew it, and we're going to save those screws. Cap head screws are much more durable and reliable than button head screws, and in this particular case, T-Motor actually ships them with cap head screws and not button head like so many brands. Most motors ship with 2 variants, 3mm and 4mm. You just need to measure the screw itself and see what you have and replace it with the same length. Out with the old. As you can see, this motor is very damaged, and we'll set that aside. In with the new. Here we go. As stated, we get fresh screws, which we will save for another time. We don't need these right now. Okay, the first thing I recommend you do is attach the motor to the arm. Doesn't matter exactly which order you start in, but just go 1, 2, 3, 4. When you do it in a star. Go crisscross. And then the last one. Again, don't tighten them, just get them threaded a few times, and then once the last screw is in and threaded, go ahead and then star pattern 1, 2 to snug, not tight. 3, 4. After they're all 4 are snugged, then 1, 2, 3, 4. About a quarter turn past snug. You want it to be now tight. And just kind of go back over them. You don't need to crank on them. You just need to make sure that they don't just back out with no effort. The next thing we're going to do is kind of measure and see where we're going to snip those wires. The frame, this is where we're going to cut them. So when we strip the wire back, we'll have a little extra. So as evenly as I can. So now all 3 wires are cut and ready to be stripped. So we're going to strip back a little bit. You can do this with your thumbnail as well. Usually this is very soft. See how easy that was? If you have a little bit of a thumbnail, you're good to go. You can use your wire strippers. It just depends on if you have thumbnails or not. This wire is very easy to strip. We don't want much more than this amount of wire exposed. That's it. If you have too much, you run into the risk of shorts. If you have too little, you run into the risk of it not making good contact, or basically being more difficult to solder, really. So this is just fine right here. Okay, twist them. Give them a good sharp twist so they stay together and there's no splaying. The wires are not splayed. And then what we're going to do is clamp them and then tin the wire, just like that. Bring up the iron, bring up the solder. Don't breathe in the smoke. And the last one. Okay, now we have them all tinned. They look shiny. That's what you want. Shiny good, dull bad. So we have 1, 2, 3. We're going to crisscross and we're going to do this one first. So again, I'm going to actually use the same tool and I'm going to just hold this near the pad over the center of the pad. Nothing to it. 1, 2, 3. Hold it there and then release the clamp. And now we're going to put the rest of the wires back in order. Again, just touch it. That's it. Until it flows. Once it flows, hold it for a few seconds without any tension. Let it cool. I kind of give them just the slightest of slight tugs just to make sure that it doesn't just pop right back off. Last but not least, again, over the center. Clean tip. 1, 2, 3. It flows very quickly with 400 degrees. You don't want to leave the heat on there for more than a few seconds at a time. And that's it. So now what we need to do is we need to inspect the joints and ensure that there's no bridging. Do this every time, just in case no one's perfect. The way I do this is with a magnifying glass. So now that I've replaced the wires and I have the motor mounted, I actually need to make sure I leave my props off. I need to get my computer with Betaflight installed, and I need to test the motor direction with a battery plugged into the quadcopter. This next part, if you've never done it, is a bit advanced. You're going to want to go watch my video on how to build a quadcopter at this point, and go to the Betaflight section, and I'll link that in the video description down below. So let's do that now. Anytime I do any sort of plugging in after I've done some work on the quad, I always make sure I got my smoke stopper installed in the battery. That is a good sign. So we're going to go ahead and unplug it. Plug it in without the smoke stopper, now that we verified that there is no short. So next thing we're going to do is in Betaflight, we're actually going to go to the motors tab, and we're simply going to acknowledge that all the props are off. That's in the lower right hand. Yes, the props are off. The second thing we're going to do is in this case, we're going to try to spin up just this motor very slowly to make sure that it's spinning the right direction. You need to make sure that it is spinning the exact same direction it was spinning before. Most of the time, the motor should be spinning as if the prop were coming into the camera if it's in the front, or into the butt of the quadcopter if you're replacing the back motor. Either way, it needs to be spinning the exact same direction as it was before, opposite of the motor on the other side. So in this case, the motor is spinning this way, no prop, I can actually feel it, so it's much safer to do it this way. Disable it, I can check the other motor. And it is spinning inward as well. Okay, so the motor is in the correct direction and wired correctly, so I don't need to make that correction. I can shut off my soldering iron and move on to the next step. The final step is basically just re-securing the wire the way it was done before. In my case, just using electric tape. And that's what I'm going to do now. So there's the blue electric tape. We want to match, right? It's a blue-black theme. So I'm going to rewrap the wires in electric tape. That's what I've always done, and it seems to work pretty well. There are many, many methods to protecting the wires, including 3D printed parts and what have you. But that's it. The next thing is you're going to replace your props and go test fly it outside and make sure she flies okay. Thank you so much for watching. Hopefully this was helpful.